Namaste everyone. So today in my video I am discussing about a very important topic, that is the electric field due to system of a charges by using a superposition principle. So before studying this derivations, I would like to explain you that what do you mean by superposition principle? What is the meaning of a superposition principle? So here superposition principle nothing but I'm going to write a expression, that is vector f is equals to vector f1 plus vector f2 plus vector f3 plus so on. What it means? What is the meaning of this? It states that superposition principle states that force on any charge due to number of other charges is a vector sum of all the forces. Force on any charge is due to a number of force or a number of other charges is the vector sum of forces on that charge due to other charges taken one at a time. You can simply remember it is that vector sum of a force is equal to the sum of vectors of other forces which contain a charges. Okay, this is nothing but a superposition principle for a system of a charge. Here, for a system of a charge, you can give a expression as a q. As you know, q is the scalar quantity and we can write it as the q1, q2, q3 so on up to qn. Okay, so this can be written. We can write it as a q1, q2, q3 so on up to qn. So moving further, so we are going to discuss our, so moving further for a derivation part, electric field due to a system of a charges. So we have to need to write a concentration part. So here I am considering that electric field is due to system of a charges, that is q1, q2 so on up to qn. So we have a system of a charges, so such that we have a q1, q2 so on up to qn are the charges, and we have a position vector. So from way to way these charges are located, we need to write the position. Those are r1, r2 so on up to rn respectively. This much of consideration is enough for this derivation. Moving further, so for electric field E1 at a point P, we have to write a equation, that is E1 is equals to 1 divided by 4 pi epsilon naught Q1 upon R1 square and R1 cap. This is the equation number 1. Here R1 stands that it is a position vector for a Q1. It is a position vector for a Q1 at a point P. This R1 is a position vector. This R1 is the position vector at a point, at a charge that is a Q1 at a point of P. This one is clear. So moving further, name it as a equation number 1. Moving further, we have electric field for second for E2. Then we have a E2 at a point P is given by E2 is equals to same equation 1 divided by 4 pi epsilon naught. Here changes. Here we have taken a Q1 because of with respect to electric field 1, and we are speaking about electric field 2, so we are taking the charge as q2 and position vector as r2, position as a r2 and vector as a r2 cap. So I hope this thing is clear for you. Moving further, similarly expression for a E3, E4, E5 and so on to En. So the same electric field expression what we have written previously, that is E is equals to 1 divided by 4 pi epsilon naught. For E1 we have taken a Q1 upon R1 square and R1 cap. So same equation holds good for E3, E4, E5 so on up to En. So by using a superposition principle. So in the beginning of my video, I have explained you what is the superposition principle and how it is implemented it is implemented, we will see further now. So superposition principle is it is nothing but there I explain on by taking a force. Okay, I took a force vector F is equals to vector F1 plus vector F2, sum of all the forces. Okay, individual force of any charge is equal to the sum of vector of all the forces of the charges. Okay, this is our superposition principle. In a beginning only I explained. So here we are taking that superposition principle in terms of electric field, that is equals to E1 plus E2 plus E3 so on up to plus En. So we know that E1, E2, E3, for all the quantities we have a constant value, that is a 1 divided by 4 pi epsilon naught. Here epsilon naught is permittivity of free space, 4 pi is a constant as we know. So vector E is equal to 1 divided by 4 pi epsilon naught, and equation stands here Q1 divided by R1 square into R1 cap plus Q2 divided by R2 square plus R2 cap plus so on up to plus Qn divided by Rn square into Rn cap. So here only one step is there to write a last equation. I will show you. So this is my last equation for this entire derivation, that is vector E is equals to 1 divided by 4 pi epsilon naught summation of I from 1 to n. So we are writing in general. This is for a 1, 2, 3 electric field, but here we are writing the in general expression. For that reason I took here I. So Qi divided by Ri square into Ri cap. So in physics, most of us used to forget that every time whenever we are writing any kind of derivation, you have to describe what the thing or what are the quantities you are used. You have to describe them, like I'm showing here. At the end of every derivation in your exam, you have to write this where. You have to write a where, and you have to write where E or vector E is the electric field. You completely write this one. Okay, then epsilon naught is the permittivity of free space. Then Q is the charge. So Q1 or Qi is the electric charge, or simply you can write a charge, and Ri cap is a position vector. This much you have to write in your exam to score a full marks. So I hope this concept is clear for you. If you have any doubts, please comment me, or you can ask me directly in the comment box. And please subscribe to my channel for a further videos, and please like and support for me. Thank you. Bye bye.